Okay, you think it's going to increase? How many people think it's going to decrease? How many aren't sure? Okay.
I don't think it's going to change.
You don't think it's going to change? Okay. Pause. Okay, so this is sort of like that timeout that some of the other people did in their presentations. This is where, so you're not my class anymore, you're my Education 548 class, you're not my 10th grade chemistry class. Here, I only have a couple friends here who are helping me out with this lecture, so I can't do what I would want to do in a classroom, but I'd want to get the kids up and moving, kind of get some of that kinetic learning going on. And what actually happens as you go from left to right across the periodic table is that atomic size decreases, which it's sort of counterintuitive because you think you're adding protons, you're adding electrons. Why is it decreasing? And the answer is because there's more attraction between the positive and the negative, and so the atom shrinks. But I would want the students to kind of figure this out for themselves rather than me telling them. I think it helps them remember that better and understand it better. So what I do is actually have students come to the front of the room and assign students to be protons and then assign a couple other students to be electrons. And then, so we'd start with, let's say sodium. We'd move across the periodic table and I'd have more students add themselves as protons and more students add themselves as electrons. And, after we've discussed why protons and electrons are attracted to each other. They would already know this, but after we've reminded them about this. So then the students would kind of see for themselves, the more of them are in the middle, the more of them form around the outside, the closer they actually get because they're getting more and more attracted to each other. So hopefully that will be a way for students who are, kind of more kinetic visual learners to remember this, instead of just trying to remember maybe a 10-second soundbite coming from my mouth. They could remember, oh, we did this activity, it took us a couple minutes, so I remember what happened, and that way, this trend, which I think is maybe one of the more difficult trends for students to remember, would be better cemented in their minds. So I'm sorry if that was a poor explanation of what I mean, but I can't really do it because I don't have any students here. So I guess I'm ready to unpause. All right, unpause, you're back into 10th grade chemistry. All right, so did that exercise kind of help you guys figure out what trend is going on with atomic radius as we go across the periodic table?
Yep.
Okay, so make sure you take that and write that on your note sheet, okay? Write that down. So, Mark, as we go from left to right across the periodic table, atomic radius does what?
Decreases.
Why?
Because there's more attraction between electrons and the protons.
Good. Great. So everyone make sure you have that written down. Another good way to think about it, if this helps, is to think of it like the solar system, right? Pretend the sun is like the nucleus. The planets rotating around the sun are like the electrons. With our solar system, what holds the solar system together? Why don't the planets go flying off into outer space?
Gravity.
Gravity, right. So it's like, if we had a bigger sun, imagine we doubled the size of our sun, or imagine that we added more planets within the orbitals that already exist, without adding planets farther out than Pluto. What would happen to our solar system? What would happen to the gravitational attraction between the sun and the planets?
Get stronger.
Yeah, it would get stronger and our solar system would actually shrink. So does that make sense how that's kind of an analogy, except we're not talking about gravitational attraction with these atoms. We're really talking about the attraction between the positive and negative forces in the atom. But it's the same idea.
Yes.
So that kind of wraps up these trends for the most part. Why did we talk about these trends today? Why is this important? Where is this going to lead, do you guys think? You're not sure?
Sure.
Remember when we first started this unit on chemistry and you guys looked at the periodic table and it just looked like Greek? It was so foreign to you. Don't you think it's cool that now you can look at an atom and just from its position on the periodic table, even if you've never heard of that element before, you could tell me something about it, right? And you can tell me something maybe about how that atom will react, right? If an atom has a high ionization energy, it doesn't want to give up those electrons, right? So, it's not likely to bond with a non-metal, say, that would want to take its electrons. So this is all leading into chemical bonding, really, is what we're doing. So, that's why this is important. And the last thing I want to leave you guys with is this really neat little YouTube video that I thought you would enjoy. So, unpause. Sorry. So the YouTube video, again, I can't really show it to you. The link, I'm going to put the link in the email that I send you to give you this information on. But it's a really neat video where some AP chemistry students took the song Throw in the Bag. It's like a hip-hop song. It's a cool song, and they changed the words to be about the periodic trends. It's perfect. It's just what we've been learning about. And I think it would be great to show the students because it's fun, but also because I think it's incredible how well teenagers and really anybody can remember the words to their favorite song, or how easy it is to remember things that you like and that you enjoy. And so, you know, maybe it'll be easier to remember some of these trends when you put them to the tune of a very familiar song. So I just think it's kind of fun, and I don't know if you get a chance to check it out, but it's worth checking out. The students who put it together did a really good job. So I guess that's my lecture. That's everything. Sorry if it was a little awkward. I've never used, I'm using a webcam for the first time. So thank you very much for listening. And hopefully you could see our board there. All right, that's it. So thank you very much.